Some last real space music for a 10-minute cosmic journey. Deep, immersive, soul-paced with evolving textures of furious solos, subtle vibration, atmospheric emotional, the vastness of the universe, stars, galaxies, and interstellar travel. No rhythm or vocalist, only smoothly, ever peaceful as a journey through space. Life's within a space music for a 10-minute cosmic journey. Deep, immersive, sound-tight with evolving textures, ethereals, subtle paths, and distant cosmic. Slow progression. Sleep in emotion, the vastness of the universe, stars, galaxies, and interstellar travel. No rhythm or vibers.
These experiments are crucial in developing the fundamental physics rules, if you will. We want a general knowledge of what controls stability in the long term in the absence of gravity. Now, from an actual pragmatic level of the humans that are going to be participating in long-term exploration and habitation, this matters because these colloidal particles, a micron across, are almost identical in structure. The same physics governs them as a lot of gel materials, and in particular materials that will have a direct impact on the health and quality of life of people in exploration and habitation, from skin creams, shampoos, washing your clothes, eating your food, perhaps medicines, being able to say that in the long term we understand that these materials will still be there, still be functioning, still be stable after months, years, and beyond in low and no gravity as a direct consequence of the understanding that we're getting from our colloid work on the space station. Now, what was exciting about the BCAT KP samples is that we were able to run those for several months. But I took some of those same exact samples and put them into the ACE experiment to look at on a microscopic level. So we're combining many of these modalities in multiple experiments to explore a wide range of timescales and length scales of the structure and dynamics of these samples. We can look at the months-long behavior with time-lapse photography with BCAT, and then we can take the same sample and put it in the microscope, which we have done with ACE. One of the great things about being at Harvard, in particular with my advisor, Professor David Waits, is again creating a long-term, stable research environment to take bigger intellectual risks. I've been in his lab for almost 20 years, and he's supported this work for decades. And that's enabled a whole host of exploratory ideas that we would not be able to do if we were under, say, more short-term thinking, short-term projects. He's a real visionary, one of the leading scientists in the world, because he's able to support and to really incubate a lot of broad-based thinking. that we've been able to put into practice here with many different experiments on the space station with NASA. And it's been tremendously valuable to me as a scientist personally, but more broadly to the whole field, because NASA has given us a stable platform, both physically with the International Space Station and with the funding to take new risks, to go into areas that other people just wouldn't have the resources to do. We're doing these experiments on the space station, and we're able to probe things like stability over year-long timescales. That's just not possible for the typical short-term thinking that a lot of other funding agencies have imposed on their scientists. And I think it's a great example, not just for our subfield, but for science in general, that if you want to open up the space for people to think broadly, to think deeper, to think a little bit beyond what's just in front of them, which I think is very important, not just for the future of our country, but for the future of inquiry in general. We see lots of things happening around the world, that NASA is almost unique in its ability to incubate this kind of deep scientific inquiry in a way that very few other places are able to do. Our data thus far has been very good. We're able to make these full 3D maps of millimeter-sized samples, which is something that we haven't even done on the ground because of the stability and the reproducibility and the engineering in this microscope. We're very excited to be here. The engineering has been great. We've long anticipated these results, and it's many years of work by a large number of people coming to fruition in our experiment this week, and it's really an enormous privilege to be able to get this wonderful level of quality data.
Vastness of the universe, stars, galaxies, and interstellar travel. No rhythm.